Aft deck, bridge, you there, Al?
Yeah, go ahead, Pete.
Yeah, going to be ready in about 5 minutes for deployment.
And you want to wrap out your side scan and sit up and down. Alright, ROV off deck.
ROV in the water, thank you.
When somebody asks you, why are you doing this? It's because it's interesting. It's curiosity driven. It is still curiosity driven science, but of course there is interest in how the Earth system works. And in the late 90s, this entire seep studies, they got a kind of a boom because there was a new ecosystem related to this. That's the clams, the tube worms, the methane-derived carbonates, the processes of anaerobic methane oxidation, and all these kind of things. So these processes we understand. But to scale and to stretch this out over an entire continental margin, that's the new thing.
One of the aims of this expedition is to better understand the distribution of methane seepage in space and time along the Pacific margin.
And one of the best ways we can do that is collecting the types of rocks we're seeing near these vents. They are called authigenic carbonate rocks.
We are going to take the rocks back to the lab and then chemically extract uranium and thorium from those and measure it on a mass spectrometer in order to determine the age of the rock.
A lot of times we don't know when we pick these up whether they are authigenic carbonates. A very easy low-tech way is to drop a little bit of hydrochloric acid onto the rock samples, and if they react, then we can confirm at least that they're carbonates.
Wanna try?
Looks very ice-like. It's a crystalline structure formed under high pressure and very low temperature and very high methane concentrations.
Seeps are often related to gas hydrate, and gas hydrate have been seen in the past and in some countries are still seen as a potential energy resource that, for example, Japan, Korea and the Chinese are still very much interested in. So this was a driver to understand seeps and to find seeps, because where there's a seep, there's gas hydrate. So there's a quite simple link.
I'm collecting these gas bubbles at the seafloor because I want to know the chemical composition. So I want to know what kind of gas is actually in these bubbles. I here have specially designed gas tight samplers. What we are doing is just letting the gas filling up the funnel. I'll ask the pilots to push the hydraulic trigger, which opens my bottles. Then it takes less than a second.
Okay, I'm ready.
Are you ready?
Yes. Yes, okay. That's a pure gas phase. That's great that something is left in there. That means we actually didn't suck in any seawater.
We want to know what the impact of these methane seeps are on the ecosystem, the habitat, but also if it has some implication for an input of methane in the atmosphere.
Although you can say, okay, you have seen one seep, now you know roughly how it works. But getting the entire depth range, the different ecological settings, the change in the ecology, and all this together is what drives us to do this.